So the second question is you're given a binary string of some length that's either or that means that's all zeros or ones. And what the binary strings represent is they represent cows that are sick. And what happens is that if a cow is sick, over the course of one night, it'll spread its sickness to the two cows that are adjacent to it. So, for instance, if the cow on the edge is sick, it will lead to it infecting the next cow over. But if, say, a cow in the center is sick, um, it will infect the two cows next to it. And the question is, given the initial string of length n, where n is less than or equal to 10 to the power of 5, I think, find the minimum number of cows that could have been sick initially to have arrived at this pattern, to arrive at this binary string of sick and unsick cows after after some amount of after like some number of days. So so the way to approach this problem is to first determine the maximum number of days that could have passed since the initial position, since the initial time and this current string. And then after finding the maximum number of days that could have passed, we can then solve for the minimum number of cows that uh okay, thanks. It's 3 times 10 to the power of 5. We can then solve for the minimum number of cows that would have been sick initially. So to find the maximum number of days, we can consider each like clump of sick cows individually. And then so we define a clump as a consecutive set of sick cows. And clumps that are on the edge behave differently from clumps that are in the clumps are in the middle. So if we consider a clump on the very edge, let's say the one here where it's 1, 1, and then there's like a 0 here. And we need to find the minimum number of cows that, or the maximum number of days that could have went by for this clump to happen. Say the clump is of length x, then the minimum number of days that would have had to pass is x minus 1. And then so this is if it's on the very edge. And this is because we can put one sick cow at the we can put one sick cow at the very edge initially, and then over time you'll continue to get the next cow over sick. And this will take a total of x minus 1 days. Then if we consider if we consider the cows in the center, like this cow here with 2 zeros on the sides, then the maximum number of days, if the length is x, then the maximum number of days is equal to x minus 1 divided by 2, and then round it down. So yeah, so if we think about if we think about a clump that has an odd size, let's say that it's like in this case it's size 3. What would have had to happen is we have to have a cow that's initially sick in the middle here. And then over time it continues to spread to the cows that are next to it until eventually it covers the entire length of the clump. And the number of days that this takes is equal to x minus 1 divided by 2. So for instance, in the case of where x is equal to 3, this would take 1 night. But then if we consider the case where x is even, or the length of the clump is even, then let's say it looks like this. Then the initial configuration has to have two sick cows at the very center. Otherwise, the sick cows would spread unevenly. So over time, it will look like this. Oops. So if the size length is x, then it will end up being equal to x minus 1 divided by 2 rounded down. So in the case of 4, for instance, it will be equal to 3 over 2, which when rounded down is 1. And this is true because we can't just have one cow at the very center, since if we had one cow, it would spread out in a length that's always odd, and it can't make the even length that is required here. So with this in mind, we can solve for the maximum number of nights that would have had to have went by before we before we get all the cows sick. Then after we know that, we can determine the minimum number of cows that are needed. And how this works is we can then consider each clump again. Say here, so here above, we can determine that the maximum number of days that would have went by is 1. And we can, for each clump, we think about placing cows optimally such that after that one night, all of the cows within that clump will be sick, and none of the cows outside that clump will be sick. And how this works is we have x divided by 2 times night plus 1. And then this has to be sealed, or this has to be rounded up. Since, for instance, if we consider a clump of length 4, and we know that it only took, or let's first go to a sample. If we consider a clump of length 2, and there's one cow that was sick initially, then what we have is 2 divided by 2 times 1 plus 1, which after being rounded up is equal to 1. And this corresponds to placing one cow here. And then if we have clump of size 3, this corresponds to 3 divided by 2 times 1 plus 1, which is also equal to 1, and this corresponds to placing a cow here. And if we made the clump sizes a little bit bigger, let's say a clump of size 4, this will be 4 divided by, which when rounded up is equal to 2, and this corresponds to placing a cow here and a cow here. And this is the minimum number of cows that it would take to get the entire string sick. And the final complexity will end up being O of n, since there can't be more than n clumps at the end of the day. And then as a note, the idea of finding the maximum number of nights and then the minimum number of cows is somewhat straightforward, but it's easy to mess up on some of the implementation details. So be careful about that, especially the cases, quite literally edge cases, where it's the cows that are on the very edge. And there's also a case where they're all zeros, and you have to be careful not to accidentally runtime error or something, since there aren't any clumps at all. So that's it for the second problem. Does anyone have any questions or?
Yeah, wait, so how did you what was like the intuitive like thought process to get x over 2 times 9 plus 1?
Oh, sure. If you, let me erase a little bit. If we think about placing a cow in the center, sorry, my pen's struggling. And then over the course of some number of days, the cows will continue to grow outwards, or like how this cow makes the cows next to it sick continues to grow outwards. And if we don't want these, and if we want to minimize the total number of cows, we want to try to have these cows trying to make other cows sick not overlap when possible. Since, for instance, if we if we were to put another sick cow here initially, we can see that they'll overlap and they'll both get this cow sick. They'll get this cow sick twice. But instead, if we had placed this cow out here, this will get more cows sick as they don't overlap. So this is why. So the if we know that it'll take night nights, right? The the like let's say area of influence of some cow is equal to 2 times nights plus one. And since we want to space out the cows whenever possible, it'll be the same as just dividing the clump length by these cows, by the number of intervals that it takes. I hope that helped answer your question.
Oh, yeah. That makes sense. Wait, so but so when you do the division, right, it always gives you one number, but how do you know like because the different positions for every infected cow? Because wouldn't that only give you like one number?
Oh, well, oh, it's like, uh, do you mean like, for instance, let me erase a little bit. Like you're asking how I would know the answers individually for this clump of size 2 and this clump of size 3 if I'm just dividing to get one number or
Yeah, wait, so like would that one number like what would that one number be like the position where the infected cows are?
oh wait, so what's the one number that you're
Like
referring to?
the x over 2 times 9 plus 1.
Oh, I see. This is the minimum number of cows needed to infect a clump of size 10.
Oh, okay, yeah. Okay, yeah. That makes sense.
Okay.
All right, yeah. Thank you.
Okay. So then are there any other questions? If not, then I'll move on to the third problem. So